every rare space event we'll actually see before we die. Lock in here.
Remember these dates. Well, why is that important? Usually we look up at the night sky and see an absolutely still, peaceful picture. It feels like the universe has hit pause. But that's a grand illusion. Right now, for example, an asteroid the size of a skyscraper is hurtling towards us at breakneck speed. In a neighboring constellation, a dead star has reached critical mass and is about to light up the sky with a thermonuclear explosion. Meanwhile, our very own moon is about to take a brutal hit, and we'll watch the flash in real time. The craziest part, these main shows won't happen in some abstract future, but right within our lifetimes. To see the first one, you won't even have to wait decades or even years, because it's happening right now in 2026. If you look at the constellation Corona Borealis, you'll see a bright new star. It shines almost as bright as Polaris, even though just yesterday there was no visible star there at all. It seems like the night sky has simply been adorned with another bright little dot. But don't let that fool you. Hidden behind...
Yo bro, this actually didn't look like a Edpuzzle video. If you know, you know if you're in high school. Or maybe even middle school, bro. Yo, my fault if I kinda look geeked. I'm tired, I had a long day at school, bro.
This steady light is the epicenter of a colossal catastrophe. In the T Corona Borealis system, a super dense little white dwarf orbits in tandem with a massive red giant. They're so close to each other that for decades, the dwarf's gravity has been siphoning off its neighbor's gas. All this hydrogen accumulates on the dwarf's surface. Temperature and pressure build up until they reach a critical point. The outcome is predictable: a massive thermonuclear explosion. What looks from Earth like a mere twinkling little star is actually an expanding wall of plasma heated to millions of degrees. But here's the most fascinating part. The explosion itself occurred 3,000 years ago. It took that light all this time to cross the void and reach us here today. Soon, this light will fade, and the dwarf will go back to doing its devouring work in the dark. But
that shit's actually astonishing to me, gang. Like, you're gonna tell me, bro, that, bro, we could be looking at a star, bro, and it's actually 5,000 light years away, bro. Like, that's crazy, bro. Bro, we can't see nothing in space like in real time, bro. Unless there's like a robot out there. You know, a moon rover, something like that.
Events don't just change the night sky. True darkness will descend upon Earth in broad daylight in August 2027. The sun will go out. It sounds like a regular solar eclipse, an amusing astronomical trick lasting a couple of minutes. But this time, the mechanics of the cosmos will align with eerie perfection. The sun will go out for an incredible 6 minutes and 23 seconds. It'll be the longest remaining total eclipse of the entire century. On that exact day, the moon will approach the Earth to its closest possible distance, becoming massive in our sky.
Yo, and if anything were to happen to like our space station, or not our space, our sun, bro, we wouldn't know after like 8 minutes, gang, cause that's how like long it takes for the sun to reach our planet. Not gonna lie, bro, maybe the people at the intergalactic space, nah, that's comics, but at the space station and up there in our gravitational pull type shit, bro.
Earth will move away from the sun to its farthest possible distance. As a result, the giant lunar disk will easily cover up our tiny star with room to spare. Such a perfect alignment of orbits is an incredible rarity. A pitch-black shadow, nearly 300 kilometers wide, will slice across the planet from southern Spain to Yemen. It'll plunge the Egyptian pyramids in Luxor into darkness and sweep directly over Mecca. What's more, the shadow will race across the planet at a terrifying speed of around 2,500 kilometers per hour. You couldn't outrun this darkness even on a Boeing passenger jet plane. But 6 minutes later, light will return. Of course, as eerie as an eclipse might seem, it's an entirely and completely safe phenomenon, one that astronomers can predict down to the second. The problem is, there are things in space whose orbits are much more difficult to predict. And just a year and a half later, in April of 2029, an asteroid the size of a skyscraper will approach the Earth. And it's heading straight into our satellite zone. April 13th, 2029. Apophis, an asteroid the size of the Empire State Building, will fly by Earth. In the early 2000s, astronomers seriously considered the chance of it colliding with our planet. An impact of that force would wipe an entire continent off the face of the planet.
Bro, but I feel like people always do that, bro. Like, motherfuckers, like, just be online. Oh no, NASA said we have satellites that can deflect that shit, bro. Like, when asteroids are finna hit Earth, supposedly, like, motherfuckers think, like, say, go like online and say, like, oh no, NASA has asteroids to deflect it, we're good. But I don't know. I don't know how factual that is.
But then, thankfully, the calculations were refined. There will be no collision. But it'll pass at a distance of just 32,000 kilometers. That's 12 times closer than the moon. Apophis will dive even closer than our ring of weather and communication satellites that are flying around up there orbiting the Earth. And amazingly, in Europe and Africa, you'll be able to see it with your naked eye just by looking up, a glowing dot sliding rapidly across the night sky. At the moment of closest approach, Apophis won't just fly by. Earth is a gravitational heavyweight. When the asteroid enters our zone of influence, the planet's tidal forces will literally begin tearing it apart. Gravity will pull on the near side of Apophis much harder than on the far side. This will trigger massive asteroid quakes, or should we call them Apophis quakes? Anyway, Earth will warp the shape of this rock as well as alter its rotation and permanently rewrite its orbit. But objects without Earth's immense mass and lacking a dense atmosphere don't stand a chance, which is exactly what our moon is going to experience firsthand in 2032. The asteroid 2024 YR4. The probability of this 60-meter wide rock crashing into the moon in December 2032 was 4.3%. For orbital mechanics, that's a
How big does a rock have to be to collide into the moon and move it?
critical threat level. The moon has no dense atmosphere to tear the object apart. A rock weighing hundreds of thousands of tons would slam into the surface at full speed. The explosion's energy would be around 15 megatons, hundreds of times more powerful than the bomb dropped on Hiroshima. The blast would kick up a cloud of debris that could be fatal to lunar orbiting satellites. New radar data from ground-based observatories have allowed us to rewrite the trajectory, the impact.
Is that why the moon has so many craters? 'Cause It's constantly getting hit by stuff.
Canceled. Unfortunately, in my opinion, because that would have been so cool. In December 2032, the asteroid will miss the moon by a mere 21,000 kilometers. By cosmic standards, that's just a hair's breadth away. But orbital mechanics do work flawlessly. There will be no collision. We can calmly and sadly watch the rock fly back away into the darkness. But as it fades away, the night sky is already, thankfully, preparing an entirely different, this time incredibly bright, spectacle for us. On this day, you'll look up and see a blood-red giant dominating the sky. It'll shine so incredibly brightly that it'll start casting its own shadows on Earth. It might seem to you like a supernova exploded out there in space somewhere, or some other mysterious threat is heading our way. But there's no need to panic. It's our neighbor, Mars, deciding to break with the usual distance and get up close and personal with the Earth. Normally, Mars hangs out about 225 million kilometers away from us, sometimes retreating as far as 400 million. But this time, it'll reach the closest point to the Sun in its orbit right as the Earth flies directly between them. The distance will shrink fourfold, collapsing to a mere 55.9 million kilometers. In cosmic terms, that's practically just an arm's length away. This will be the historical record of the century. The last time Mars came this close was back in 2003. In August 2050, you won't need billion-dollar orbital telescopes. Through the cheapest of amateur telescopes, you won't just see a tiny little red dot, but the whole shebang, the angry red planet in all its glory, complete with its ice caps and global dust storms. This close encounter with Mars will be the main astronomical event of 2050. But 11 years later, the sky will present us with another epic.
Brody, in 2050, I'm not going outside to see some rare astronomical event, bro. I'm gonna be chilling in my crib, bro. Popping a beer, bro. Just have a beer belly, bro. Probably not a beer belly, but you know what I mean.
Back, one humanity has been waiting for over half a century. Can you guess? Yeah, that's right. Halley's Comet. In the summer of 2061, Halley's Comet will appear again in the night sky. And this ain't just any old flying chunk of ice. It's the first comet in history to prove the universe runs on a very strict schedule. So why and how did it become the most famous comet in history? Well, in this case at least, size really isn't that important. It became famous because it helped humanity stop fearing the heavens. Until the 18th century, comets were considered harbingers of the apocalypse. They appeared out of nowhere and sowed panic in the streets. But astronomer Edmund Halley destroyed that fear with math. That's right, he proved that these objects that had so terrified Europeans for centuries, they weren't different omens of doom, but the very same rocks returning again and again on a clockwork schedule. Halley's Comet, tethered to the sun by an invisible gravitational chain, comes for a return visit every 76 years. And by the way, it's the only comet that a human being has the chance of seeing twice in their lifetime. During its last visit in 1986, it was, frankly, disappointing. Earth and the comet were unfortunately on opposite sides of the sun on that pass, at a massive distance from each other. So for most people on Earth, the legendary comet looked like a tiny, blurry little gray smudge. People had run out and bought binoculars in droves, but even then, seeing anything impressive was difficult, to put it mildly. But in July 2061, orbital mechanics will give us some payback. We'll be on the same side of our star at the perfect distance. We'll finally be able to see that magnificently bright tail in all its glory. By the way, that tail is actually the comet boiling alive. As it approaches the sun, this 15-kilometer wide chunk of dirty ice will be roasting in the vacuum of space. It'll shed millions of tons of matter, fly past us, and dive back into the darkness until 2134. It'll leave behind nothing but a long trail of dust. So, Halley's Comet is a quiet, predictable show, just ice melting in the void. But for the next item on our calendar, we'll switch genres to something that will show us true primal fury. In 2083, a new star will suddenly flare up there in the skies above the Earth. It'll appear out of nowhere, and in a matter of days.
Brother, 2083, bro. Bro, we're gonna be like hella old, bro. Bro. Yes, bro. Niggas in high school right now. You're in freshmen, bro.
Become the brightest point in the night sky, outshining Sirius and Venus. For a few weeks, this light will alter the familiar pattern of the constellations. You might think it's a supernova, the death throes of a giant star. But this isn't the death of one star. No, this is the catastrophic head-on collision between two. Right now, the V Sagittae system is a pair of dim stars locked in a gravitational death grip. A dead white dwarf is literally sucking the plasma out of its neighbor. Because of this, they're rapidly losing orbital speed and spiraling towards each other. This is good.
Yo, my fault. But you know what I was thinking, bro? Like, bro, when we're old, I was having this conversation with one of my homies in school, bro. And like, bro, we memes from this generation when we're older are gonna sound mad corny to the newer generation. And like 2083, he said? Yeah.
So cool. In 2083, the distance between them will drop to 0. The white dwarf will plunge into the core of its neighbor. This isn't just a collision, it's a fatal merger that will trigger a ginormous thermonuclear explosion. Eventually, the glow will gradually fade, leaving behind one star instead of two. This is the largest catastrophe of our century that we'll be able to see with our naked eye. Or hopefully you have two. But even this merger of two stars pales in comparison to the event awaiting us next. I can't talk. I'll call you in 5 minutes.
Bro, that be happening to me while I'm recording, bro. Okay, mad annoying.
March 2092, those who point their telescopes at Jupiter will see something unthinkable. The planet's 4 largest moons will disappear, merging into a single gleaming point. After the thermonuclear explosion of V Sagittae, you might think we're going to witness another massive cosmic collision. But this time, there will be no catastrophes. This will be the universe gifting us with a mathematically perfect optical illusion. Io, Europa, Ganymede, and Callisto orbit Jupiter on the same plane. In 2092, Earth will pass perfectly through the plane of their orbits. Orbital rhythms will align in an exceedingly rare parade. Some of the moons will pass directly in front of Jupiter's disk, blending into its clouds, while the others will vanish into the giant black shadow behind the planet. Even better, the moons will begin to eclipse one another. Massive Ganymede will cast its shadow directly onto the ice of Europa, blocking its light for the earthly observer. This deceptive geometry will only last a couple of hours. Then the moons will emerge from the shadows and the Jupiter system will return to its usual state. We might actually witness with fucking piece of shit. Right now, above us, There are events already set in motion, some unfolding slowly, some building towards moments we might actually witness within our lifetimes. The sky is not static, it's a timeline, and it's moving. All it asks is that we remember to glance skyward. By the way, if you're enjoying this new format, I'd be absolutely delighted if you subscribed, turn on notifications, drop a like, and of course, let me know what you
Yo, crazy. But I got you good trust. Anyways, I'm out.